you're working on a toy project, it's not obvious what their value is. Because, you know, a typical project you do in school, what happens? You work on it for a couple months, you give it to the professor, she says B or A, and then that's it, right? Done. No one ever touches it again. So why do you need testing? Why do you need monitoring? Why do you need documentation, right? One person looks at it, gives you a grade, and it's done. So these tools are, their application is kind of, it's hard to see their point when you're working at a project like that. Another aspect, another thing I like about trying to give you projects that at least hopefully other people will use. We can't always guarantee it, right? You can actually have a commercial startup and wind up working on a project and no one ever uses it and you close, right? But we're at least going to try to build software that will be useful to other people and that hopefully will have a lifespan beyond this course. And in some cases, we know that it has a lifespan beyond this course because, for instance, the software that we put up the course material on was built by the people in this course, and we're still using it. So the course material you have, and I apologize, it's posted on the main class's website, and as soon as we get out of this class, we'll sort it out and get all of you added. But you'll have access to that. But this course material website we're using, which includes interactive quizzes and things like that, was built by people taking this course. So we know that some of these projects will have a lifespan beyond this course. So another nice aspect of this is these are public open source projects. They're intended for real use. When you go out and apply for jobs and people say, what have you done? Say, here's the GitHub repository for what I've done. Go have a look. And here's, oh, you want to run the actual server. So if they want to see what work Dennis has done in React, he just points them on the internet and says, here's the React interface I built, right? So he has no trouble showing people, here's the quality of my work, here's actual stuff I've done, which I think will give you a nice leg up. A tip, when I think this is mostly juniors and seniors in here, right? Yeah. Yep. Sophomores can get in by special permission, but I don't remember anyone asking. You're going to be out applying. Present your work as work on open source projects, in this case, because it is, right? Companies, if you say, well, I did this class project, companies go, oh, yeah. If you say, I worked on this open source project, companies go, oh, you did? Oh, okay, let's see that. So that is much more impressive to them. And since this is a class project, you never want to lie on your resume, right? But you want to, you're marketing, you're presenting yourself, you present things in the best light possible, right? So this is a class project you'll be working on, but it's also a genuine open source project. Everything is out there on the internet. We have other contributors from outside NYU to some of these projects. The New York City project certainly will have other contributors. We're also looking at working with Wayscript this semester, a startup down the road. They have a project they're interested in us participating in. So present your work that way when you're out applying. Okay, so I've talked some about the way we're going to work and why things will be different. I'm going to point out some other aspects of how this is different as I present today's material. And by the way, what's the official listed time of the course? 11 to 1:40. Yeah. So typically, we're not going to go that long. People should be ready to go that long, but typically we're going to end in under 2 hours because the focus of the course is on practical work, and we want you to have time to meet with each other during that time because you're going to be in teams. So you should have time to go gather at a table there and discuss your project together. Most often I will not go until 1:40. So you should be ready to go meet with your team and talk about what your work for the week is or something. But I'm not going to talk that long, almost never. So we do want to talk about so the course is called Special Topics, right? DevOps. So what is DevOps? Does anyone have any notion at this point? I mean,
the process to develop and deploy software on the servers and the cloud.
Yeah, great. Okay. Server, we could be deploying onto client machines too. Often it's onto servers and clouds. But people were deploying onto servers and into the cloud for a long time. So does anyone have a notion of what DevOps in particular, so rather than just software development, right? That's something that, clearly anytime you're trying to create a program, you have to do software development. DevOps, I sometimes tell people taking the course, often, that we could call this course Modern Software Development Techniques. And that would be a fine name for what we're going to study. DevOps happens to be the catchy phrase that's out there now for this collection of techniques. And what I want to do today is give you some background on where these ideas came from, what they entail, how they're different than not so modern software development techniques, right? So what other ways might people develop software? Put your phone away, please. Sorry. Yep, thank you. If you have something you need to respond quickly to someone, just go and send out the text you have to. Sometimes, your friend urgently needs to know what bar to meet at tonight or something. Well, okay, that's an emergency. You have to text them. Send that out and then put your phone back away. The big thing is not to sit on your phone, right? Because then your level of attention is going to drop way down if you do that. So we want to know, okay, if DevOps is a way of developing software, we don't really know what that way is unless we know what other ways people might develop it. I've actually had the experience of having someone come into this class and think, well, okay, this is just they had an internship at a company that was agile DevOps. We're going to see the relationship of these terms. And they thought, well, what is this? This is just the way software is developed. What's the big deal about this class, this DevOps thing? And then they wound up consulting with a company that was doing things in the older way, and then they came back to me and said, oh, I didn't realize that, wow, this is really different than the way some companies are still developing software. So let's dive back in time a bit. I want to give you, so this might seem like, what's the point of this historical excursion where I'm about to go on? If you don't know your past, you won't know your future. History is important to understand. I was trained, my PhD was done under the world's top R.G. Collingwood scholar, and I learned from Collingwood and my advisor that to really understand something, you have to understand it historically. Even if it's a scientific theory or a mathematical theorem, right? If you want to understand the theory of relativity, you have to understand what it was replacing and why it was an adequate replacement for that. If you want to understand quantum mechanics, you have to understand classical mechanics and why quantum mechanics was a necessary replacement or supplement to classical mechanics. So if you don't understand the historical setting of what you're doing, you might be able to technically do it, but the depth of, you don't have a real understanding of why we do things this way. What is this stuff for? What's it in contrast to? So up until 1700, if someone was manufacturing something, and when we do software, we're manufacturing, right? It's something that it's not easily touched, right? But it's still, we're making a machine. It's a very detailed and complicated machine. But we're creating machines that will take inputs and transform them into outputs in an orderly fashion, right? This is what all our software does. People who manufactured things did craft work. We had craftsmen, because they were mostly men at the time, or craftspeople, who knew how to manufacture a wine barrel, or they knew how to manufacture a wagon wheel. They knew how to build the wall of a cathedral. They knew how to build the roof of a house. They knew how to construct a well. And these people understood all the aspects of their job and understood the job in the context in which the job had to occur. So we had people, and they learned through a process of apprenticeship, and they became a journeyman, and then finally became a master craftsman. And so they went on the job. In general, there was no schools for these things. You wanted to become a cooper. A cooper is someone who builds barrels. You wanted to become a cooper, you went and found a cooper. And you apprenticed to the cooper, and the cooper taught you all the aspects of making a barrel. Somewhere, starting in the Italian wool trade, for instance, people began breaking out the parts of a craft and making each job more and more specialized. And this built momentum to the point where in 1776, Adam Smith is going to write The Wealth of Nations and talk about how the greatest increase in productivity comes from an increasing division of labor. Things were going to be broken down. He talks about a pin factory where it used to be one person made pins, but now one person just makes the pin head, and another person just cuts the metal into the right length, and another person draws out. I don't know that much about 18th century Scottish pin manufacturing, but there were a number of jobs you could break it out into, right? And people could make 100 times more pins than if they were working individually by taking advantage of the division of labor. And this no doubt is true. Even Adam Smith, however, though he recognized the big increase in productivity that occurred with the increased division of labor, said, well, it does tend to make people as dull as a brick, basically. That's not quite what he said. But, someone who spends their entire life just making the head of pins, that's kind of stultifying. It's not the most interesting work in the world, right? It doesn't really challenge your imagination much. He did note that people doing this, if given the opportunity to do so, we have more pens here, that's nice. If given the opportunity to do so, would innovate with their job to try to make it easier because they had to repeat this thing so much. Sly Dunbar and Robbie Shakespeare are the top reggae drum and bass combo that ever existed. They've recorded something like 20,000 different singles they've been the drums and bass on. And someone asked Sly Dunbar, how is it you wind up coming up with so many little variations? He said, you have to play the same thing 20,000 times. You start to think of ways to vary it, right? So this is a factor that will occur, that it can prompt people, if they're given the chance, to try to innovate with the process. But what happened let's see how, well, this one doesn't even have a nub. We have a garbage can, Tara Pal. Thanks. This division of labor was extended and deepened and pushed to its extreme. And where does it hit its extreme? In the 20th century factory assembly line. Henry Ford is famous here as a real person pushing this in this area. But most manufacturing picked up on this. We have Taylor. Taylorism was a movement to measure every movement a factory worker did and try to, if their hand was moving too far up this way, you'd make it so the part was here so their hand could move less far. And Taylor said that what we're going to do is we're going to push all of the intelligence is going to be pushed up into highly educated people would have advanced degrees and extensive study in the theory of how to produce, how to manufacture products, and they would devise a rational plan for the factory. And the job of the rest of everyone else at the factory was simply to execute that plan. What this essentially meant was that the only people who were supposed to think were these people. That everyone else was essentially functioning as a robot, a piece of machinery themselves. The only reason human beings were needed in these slots is that they couldn't make anything, with fingers as flexible as a human being to screw the cap on jars, for instance, or to put a screw in the side of a Ford car. So this relied very much on these people being able to make an abstract plan for the entire course of production that saw the future far in advance, because they have to make this plan and it has to be propagated to 100,000 workers and take care of the next 3 years of manufacturing this car. These people needed huge foresight. They needed to be able to incorporate into the plan all of the details of what would occur down at these lower levels. It required that products be extremely standardized because the plan was already incredibly complex, right? These people had a huge planning job at the top, and any variations only made it worse. So we have Henry Ford telling in newspaper reporter, oh, my customers can have any color car they want as long as it's black. So that was it. A single color, no options. The cars were cheap because they achieved big economies of scale. They were able to pay the workers pretty well, so the workers, for the most part, just put up with how boring and repetitive the job was because they were getting good pay, good benefits. Ford would give them a nice retirement package, pension. So the mid-20th century, it looks as though this is the way to manufacture. Now, we're going to do a slight detour in our story here because there's a development in the 1950s and 60s that only later enters back into our software engineering story. And that is something that what happened at Toyota in the 50s and 60s, we're going to find enters into our picture again and again in different interesting ways. So we'll take a slight detour. While the American car companies were at this point dominating world production, right? Japan had just lost World War II. The country was devastated, right? It had suffered an incredible amount of bombing. It was not particularly wealthy. It had been a fairly wealthy country, but it had expended tremendous resources fighting World War II, and then had lost it. So the country is in rough shape. And there's a small manufacturing company called Toyota. They had been making sewing machines, and they decided they were going to make cars, and they were going to be competitive. Well, how can this company in this country whose manufacturing base has been devastated with a smaller domestic market than the US companies possibly compete against these giant American car manufacturers? And Toyota realized that there was no way they could go head-to-head with the American manufacturers. This wasn't going to be possible. There's no way they could do what Ford was doing and actually compete with Ford. What Toyota did was turn the whole assembly line picture that was supposed to, at this point, looks like it had won. They turned it on its head. They said, instead of absolutely standardized products, we're going to be extremely flexible, and we're going to be able to respond rapidly to customer demand and produce exactly the kind of car our customers are asking for. Ford's model was, we'll produce the car we thought of, and then we'll push it onto the customers. So down at the dealership, you gave the dealer a quota. You said, you have to sell 1,000 cars this quarter or whatever. And just tell the customers this is a great car, sell it to them. Toyota said, no, we're going to listen to the customers, find out what they want, and make it for them. So we are going to reverse the Detroit, because that's where the American car manufacturers were, Detroit. We're going to reverse the Detroit model of manufacturing. instead of pushing a standard product out because we see it's cheap to make and easy to make, and figuring out how to make the customers think this is what they want. We're going to find out what the customers want and produce that in particular. How are we possibly going to have this flexibility? One of the things the assembly line was doing was everything had to be absolutely standardized to fit into a master plan, which meant there was no flexibility at each workstation. Toyota said we can only do this if each of these people, everyone, we use the intelligence of every one of them. We need to draw on the intelligence of every worker we have. And we say, okay, look, suddenly customers want leather steering wheels, not plastic. How are we going to switch? So we have to rely on the intelligence of the person at the steering wheel station in the factory. Because the planner can't possibly know all the details of that, right? No person can take all that into their head. We have to rely on the intelligence of that person and say, how can we transform your workstation? Help us. Let us know what we can do so that we can make leather steering wheels instead of plastic or vinyl, whatever. I never worked in the car industry, so I have to stretch a little for examples of what options we might have on cars. They want maybe the speedometer used to do this, and they said, no, they want the speedometer doing this now. How can we make that change? So the intelligence in Toyota's model was distributed throughout the entire production process, and everyone had to be aware of more than just their own tiny part. They couldn't operate as a machine that simply took this plastic and plugged it in here, right? They had to know, if we change this to leather, that's going to impact the people who are doing the finishing of the dashboard because they're using this spray, and that spray will destroy the leather. And the people right before us, this will impact them too. So people needed a broader scope, a broader understanding of what was going on. Another thing, with Toyota, you had distributed intelligence, pull manufacturing, Ford is relying on, we're gonna win by making 5 million cars all exactly the same. We can make them really cheaply that way. If Toyota wants to be flexible and respond to customer demands, what's going to happen to so we call this a batch. Ford is going to make a batch of 5 million cars at once. And this is how they're going to make money, because it's going to be cheap to make all these identical parts, 5 million of them, and so we can sell them cheaply to people. Even if it's not quite what they want, we'll convince them. We've got ad men, right? So this was the height of that whole advertising thing we see in the Mad Men show, right? So what's the role of these people? That's to convince the people that they want what is being mass manufactured. So what's going to happen to Toyota's batch size if they're going to be extremely flexible and respond quickly to customer demand?
Would it cost more?
Well, you're not going to get the economies of scale, but right, small batches. Small batches, responsive to feedback. So they have to put out small batches. They also strove for 0 defects, because they're not getting these huge economies of scale, um, so just a little break in our story. This is happening in the 50s and 60s. And it takes a while, but it hits American manufacturing. It comes out beyond Japan, beyond Toyota. And in the 70s and 80s, American manufacturers begin to adopt these principles because it turns out that Toyota was, by the 70s, was doing better than the American car manufacturers with their huge economies of scale, because people liked getting what they want instead of being told what they want, for instance. So this became known as lean manufacturing, and lean was a huge thing. It's still, still studied today, but especially in the 80s, American manufacturers began adopting lean. And we're going to see this feeds back into our software story in just a little bit. Meanwhile, back in the world of assembly line, we have these American companies who are succeeding for the moment with these big assembly line processes, and now software is becoming more and more important to them. So they say, well, here's a new thing we need to manufacture. How should we manufacture it? Well, just like we do cars and blenders and washing machines. We're going to make an assembly line. We're going to have a bunch of planners, and they're going to be able to envision the entire plan for the software. They're going to know exactly how the software should be. And then they're going to issue a document. Thank you. We are going to set up an assembly line for software. And we're going to have these real bright people called analysts. And the analysts are going to talk to the customers or the customer's representative, and they're going to figure out exactly what is needed. And they're going to make a detailed plan of every single thing that has to be done. And they're going to hand this to the designers, and the designers are going to take that analysis document and make flow charts and things like that that are closer to what a computer does. And then those things will be handed to coders. And, the coders, we don't expect them to be very bright. They are able to look at a flow chart and type in COBOL code based on what they see in the flowchart. They don't really need to think much. They need to be able to know what COBOL command is equivalent to this thing that the designers said had to be done. And so coders could be, fairly low-level workers. They're not supposed to really ask questions or innovate or think too much. They're supposed to take the design specification and type it into code. And then, of course, because these people foresaw everything, they had the whole picture, this last phase should be really easy. These people, it was all mechanical, right, from here down, and they just typed the code exactly as it was specified, And maybe they made a typo now and then. So we have a little bit of testing, and then we give it to the customer. Does anyone know what this model of software development is called?
Waterfall.
Waterfall, right. This is the waterfall model. It dominated software development because it was seen as the water flowing down, right? This was the waterfall. Things proceeded in a orderly fashion in this way. Everything was controlled from the top down. The CEO only had to talk to the analysts. Those programmers were, dirty, hairy people. Some of them had long beards and stuff. CEO didn't want to talk to them. The analysts wore business suits and, could talk business lingo. CEO was comfortable talking to them, and this seemed nice, and they could say, okay, we give you this analysis, and this phase will take 3 months, and this will take 3 months, and this will take a month. So in 10 months, the customers have the software. Well, occasionally this model worked. More often, this phase took 3 months because the analysts didn't necessarily really understand the capability of the computer systems. The analysis document wasn't necessarily so easily translatable into flowcharts and so forth. So maybe, although this took 6 months now, this phase, and because the designers didn't really know the language and the operating system and what database we had and how the different parts could communicate to each other and what we could do practically in terms of processing. So this was supposed to be 3, 3, 3, 1. So this would be 3, 6. Oops, you hit the coders, and all of a sudden it takes 12 months because these people didn't really know the details. And it turns out that because these people weren't involved in these earlier phases, they didn't understand necessarily the language that was written up in this document. These people may not have, when you actually go to code something, you have to think of all the branches, all the inputs that might come in. These people only thought of like the obvious inputs. When we got to this phase, this turned out to be a mess that was produced. And this took 24 months, and then the project was canceled because it had gone on so long, and management was sick of it, and they started again. This is a common story. The second programming job I had, they were converting PDP 11 program to Unix boxes. So it was written in PDP assembler, and it had to be converted to C for Unix. And I started, and I was told, okay, so listen, we're in the very final phase of the project. And so just to push to the finish line, we're going to ask everyone to work a little extra every day and to come in on the weekends and not take vacations, just for this little final phase of the project. And then once we finish, we'll go back to normal. I said, okay, all right, I can do that. And about 4 months went by, and we're still in the very final phase of the project. And there was a guy who had been there when I got there. And I said, Bob, how long do they expect us to be in this small final phase of the project? And he said, I don't know, but I got here 3 years ago, and we were in the small final phase then. So they had literally spent 3 years in what was supposed to be the last month of the project. And so how can this happen? Well, the stuff being produced up here is all abstract ideas, right? And you can't ever see it working because it doesn't do anything. It's not a product, right? The users can't, What was produced here often for a big system would be a 500 or 1,000 page analysis document. So imagine going to the person, your human resources department. You go to HR and they have a new hiring system. And they want to know, I wonder if they're doing the software the way we want it. And you go, well, here you go. Boom! And you give them 1,000 pages of analysis document and say, just read that, and then you'll see if we have it right. I mean, the people would be asleep by page 3, right? You can't get the user to read these things. What the user can actually do, though, is sit down and try your software and say, oh, no, that's not correct. That's not the way we need that to work. This produced repeated disasters. Sometimes it worked. Sometimes especially if the system was straightforward enough. If you're producing an accounting system and people have produced 1,000 accounting systems and you have a bunch of analysts and coders who have worked on these, you're producing something that's fairly standardized. Probably you can do it again. But for instance, if you're producing an air traffic control system, which there's not so many of in the world, and they have unique requirements, and the requirements are always changing, this model doesn't work. And the evidence of it not working, the Federal Aviation Administration, the FAA, is the American body that governs U.S. airspace, right? What the control towers have to do, what the safety requirements are, when you can get authorization to take off, when you get authorization to land, right? You people know what vacuum tubes are?
They were the very early thing in the computer before we had silicon.
Yeah, you had your bits were actual little vacuum tubes, and there was a charge in the tube or there wasn't, and that made it a 0 or 1. They always used to start computer science courses with a bunch of pictures of ENIACs and giant rooms with huge computers. I don't know if they still do that. They'd get the little history chapter at the beginning. That was very standard. Every book, they could pad out the book a little by chucking in some pictures of, I recall a picture of these people, like a couple guys, and they got a hand jack and they're struggling. And they've got this giant thing, right? And what it is, this big thing that takes 2 men to lift up this ramp was a 10 megabyte disk drive for an IBM 360. So not 10 gigabytes or 10 terabytes, 10 megabytes. Vacuum tubes were the first memory, right? In the early 2000s, the FAA was the number 1 consumer of vacuum tubes in the world. And do you know why? Any guesses? Why was the FAA? We had gone through magnetic core memory and transistor memory and microchip memory, and right? This is like 4 or 5 generations back memory. You know why the FAA was still consuming so many vacuum tubes?
Their code worked on this system.
They had multiple failed waterfall model attempts to rewrite the software. They were still running the software from the early 60s because they had repeated failed attempts to build a new system that would run on newer technology. Hopefully we're not still consuming so many vacuum tubes. Excuse me. Put your phone away. Thanks. Again, I don't mind if you just take it out for a quick message or something, but don't sit on it typing on your phone, right? Because you're missing the lecture. So, people noticed that there were other situations where this model wasn't followed and we seemed to get good software, particularly PCs came out, right? We got the Atari and the Commodore and the Apple. Apple II was the first one that was widespread. And no one could force these. There was no CEO to force someone doing a new game for the Apple II to follow the waterfall model. And these people were producing lots of software, and there was no 1,000-page analysis document, right? There was no big design. The people seemed to just code and try something out and see how it worked, and they'd show it to their friends, and their friends liked it, and they'd say, oh, okay, great, let's keep coding. This waterfall model wasn't being employed, and these people seemed to be producing a lot of useful software. In fact, a lot of this software was challenging mainframe stuff, right? Up until 1984, 85, in a corporation, you had centralized computers and people accessed them through a dumb terminal, right? You had a terminal on your desk that was wired back to a central computer. But people were starting to buy personal computers for business and put them on people's desks. Even though at that point there was next to no networking, when the main network you had was you copied your spreadsheet to a floppy disk and you walked it down the hall, you said, here's the spreadsheet. That was the main file exchange protocol. Nevertheless, the software was letting people do what they wanted to do. And these people were competing, right? They didn't have to please the CEO of their corporation by showing them that they had followed this method. They had to please customers and get working software into the customer's hands as quickly as they could, because someone else in a garage down the street was trying to do the same thing. And if you got your software in their hands first, they were likely to learn it, and then they'd, hey, I like this, I like Lotus 123, I'm not going to try this other spreadsheet. There used to be has anyone heard of Lotus 123? That was the application that drove personal computers into corporations. It was Excel. It was the Excel before Excel existed. So it was an early spreadsheet program. So what happened when people began recognizing that these PC people were able to develop and outperform these people in the corporations, even though the corporations had more resources? The PC people just looked like a bunch of dirty hippies, right? How are they beating us making this software? So people began rethinking the way they were making software. And this finally resulted in what's called Agile. How many people have heard of Agile development? Very good. Now, Agile itself, there is something called the Agile Manifesto that came out in around 2001. Tirapal, you have your phone? Could you look up Agile Manifesto? I used to have a copy on my wall, but then they moved us. So we'll get this, we'll read you some of the principles from this. But basically, what the Agile people said was, look, the best evidence that we're making progress is that we actually have working pieces of software. The best way to know if we're getting the customer what they want is to put that software into the customer's hands. The best way not to waste time building something that's not going to be pleasing, that's not going to do what they want, that misses the point of what they're after, is to put it into their hands frequently. Thank you, Tirapal. So a look at some of these things. You know, like these manifestos that tend to be a little overblown, but this stands up well with time, I think. Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. We welcome changing requirements, even late in development. Now, one of the things about the waterfall model, the requirements had to be locked down at this point because no one else is allowed to make a change in this document. So when the analysts are done, that's it. There's a new law passed, and the way the software works is invalid. Too bad, the analysts are finished. There's a new competitor, and we need to be able to compete with their processes. Well, too bad, the requirements are finished. Thanks. So Agile embraced the idea that requirements would change, deliver working software frequently with preference to as short a time scale as possible. Business people and developers must work together daily throughout the project. Build projects around motivated people. Working software is the primary measure of progress. Agile processes promote sustainable development. Simplicity, the art of maximizing the amount of work not done. Let's see, there was something about the best way of conveying information is face-to-face conversation. This was totally, in this model, the coders never saw a customer. They were kept as far from the customer as possible. Only people who ever saw a customer were these people, and they produced the analysis document, and that was now the blueprint, and you just followed the blueprint from that point on. So what happened as Agile came to gain acceptance? And I worked in an Agile environment before I had ever heard the term Agile. My last gig when I was a full-time software engineer, I was working at a company. We traded our own funds, mostly. We also did some stuff for other people. But I was writing the option trading software. And my desk was 100 feet from where the option traders sat. And pretty much every day, almost at least 3 days out of 5 in a week, I would walk out to the trading floor and I would sit with the option traders before the day opened or when they looked not too busy and say, hey guys, how's it going? Is there anything you need? And they go, oh yeah, could you make us a little window that pops up and shows us this theoretical value on this option if we click here? And I'd say, okay. And I'd go back to my desk. I'd program for 2-3 hours. I'd look, say, okay, I think that's it. I'd walk back out onto the trading floor. I would say, all right, restart the program. Okay, click there. Is that what you want? And they would say, oh yeah, that's excellent. Or they would tell me, no. We need that red, not green. Okay, I'll be back in a couple minutes. That's easy. I didn't know that this was called Agile development, but that's the essence of what Agile development is. You work in small batches. You work on a pull basis. You build the things your customers are asking for, not the things some analysis document says you should build. One of the things this required was that you had to put in every feature that you thought the software might need in the analysis document. The users were motivated to ask for everything they could possibly imagine. Why? Because it's going to be 3 years before they see software. If they only ask for a couple features, they'll wait 3 years and get a couple features. That's no good. They better ask for everything all at once, because it's going to be 3 years before they get a new round or new release of software. So they have to ask for everything. It turns out that when you build this way, 50–60% of what you build is never used. But it's all a source of bugs, right? What's the least buggy feature your software product can possibly have?
No feature?
Yeah, the feature you don't build because you decide it's not really needed, right? So you build a minimum amount of software. Just what the customer needs most today. These people were busy, they were trading options. They knew what they needed. They weren't going to ask for something frivolous. They knew, oh man, today I made this trade. I would have liked to see this number. So they were asking for what they knew they really needed, and I would build that feature and give it to them. And then they could give me immediate feedback. So responsiveness to feedback, right? I had to know what they were talking about, though. I was talking to the option traders. I had to know what they meant when they said, oh, so look, I want to be able to look at all the February puts for this stock. Well, I had to know what that meant, right? So the intelligence has to be distributed. People have to understand each other's roles in the organization. Because we're releasing all the time, I wanted to make sure I wasn't losing them a whole batch of money. I would test my changes right away. I wasn't handing it to some testing group. I would test it, and then I would sit next to them while they tested it. So we're working towards zero defects. So Agile was discovering on its own what Toyota had found in the 50s and 60s in terms of automobile manufacturing. And it turns out that there was a lady, Mary Poppendick, who was at 3M. The people who make, they make Scotch tape and Post-it notes, and Minnesota Mining and Manufacturing. They make a lot of stuff. Big manufacturing company. And they had adopted Lean. So they were doing lean manufacturing. Though this is a little bit aside, it's worthwhile having little detours sometimes for interest. You know how Post-it notes came about? Does anyone know the story of Post-it notes?
There was some an engineer was trying to telling how to make something very sticky, but he actually found something which was very easy to peel off.
Right. The chemist working on this was trying to make like crazy glue, essentially, or gorilla glue. And he failed. He had a total failure. It's like, oh man, this glue it's not super glue at all. And he said, well, I guess, this is junk. But he said, well, maybe there's some use for it. And it kicked around 3M for a couple years before someone said, hey, I've got papers all over my desk and they're a mess and I can't keep them organized. What if we put a little of this glue on the back of the paper and then I can peel them on and off? And because 3M was flexible enough, there wasn't an analyst telling this chemist, you have to produce exactly this. He had the flexibility to produce Post-it notes. And, of course, 3M is very happy that they gave him this flexibility, right? Because there are obviously a big hit. So Mary Poppendick is at 3M, and then she wound up, I think it was a different company, but she wound up supervising a software project. And she got there, and they were doing this. And she went, mein Gott, what is this? What are these people doing? This is not how manufacturing works. This is idiotic. Why are they doing it this way? Why don't they produce a small prototype and we can try it out right away and then produce a little improvement and we check that out? Why aren't they doing lean manufacturing like we are and the other parts of 3M? And she and her husband wound up writing a bunch of books on lean software development, and at some point the lean and agile people recognized that they were really talking about the same thing. I introduced this to say that this thread flowed back into software development, and we have the name Lean. But Mary and Tom Poppendick began writing books like Lean Development and Agile Methodology. So they recognized that they were talking about the same stuff. That really they're overlapping, that the Agile people had kind of stumbled on this without really knowing that Toyota had done it before them. Mary Poppendick knew it was coming from Toyota, but nevertheless, they arrived at very much similar points. I don't think there's anything much in Lean or Agile that contradicts anything in the other. So it's good to know both terms. Agile is certainly the more common one, but there is a whole bunch of software books and so forth referring to it as Lean. And Lean historically, points us back to our ancestor at Toyota. And it's good to know that, hey, this worked in manufacturing even before it worked in software. Although, the earliest software in the 50s, when it was just some people largely at universities bringing up machines themselves, was done in a more agile fashion. It would have been as it hit the corporate world in the 60s, the corporation said, we need to manufacture the same way we do on our assembly line, top-down planning. We tell everyone what to do. They're just cogs in the wheel. They just carry out the instructions of the bright people at the top. So we got Lean and Agile. And where are we now? The Agile, do you have the year for the Agile Manifesto? Something like 2001. They might have a copyright or something at the bottom. I knew it was around there. So Mary Poppendick is starting to write these books in the late 90s. So the Agile Manifesto is 2001, late 90s, early 2000s. The next thing that hits, what's starting to really take off in the early 2000s?
Internet?
The internet, right. Up to that point, companies, Paul Krugman, columnist for the New York Times, had probably his most embarrassing column in the late 90s. He said, this whole internet thing is going to be no more important than fax machines are. And a lot of companies said, who wants to shop online? That's stupid. Ordinary people, sure, nerds want to go online, right? But who's going to want to type online to their friends, right? That's stupid. No one's going to do that. They want to talk to their friends. There's a lot of skepticism. But in the early 2000s, this was fading. As it turned out, people did want to shop online. And people did do a lot of typing to their friends. And what do you think? What's the huge change the internet makes in the relationship between the manufacturer of software and the customer?
Easier connection between them?
Well, so let's say it's 1995, 1997, and a new version of Microsoft Word comes out. How do I get it?
Download it online.
You're thinking, see, you're too young.
Well, you had to order it and buy from a store and have to buy.
You got discs. You got, by this point you're getting CDs, right? But you got Microsoft to mail you CDs. And this also meant the software developers had to press CDs, which, is a little bit expensive, right? You don't want to redo it every day. You want to try to get one stable version on CD and leave it there for a few months, right? The people have to actually wait for it. People went to a store and got the new version. With the internet, there's now delivery is instantaneous and free, essentially. So what does this mean as far as how often we can put new software in our customers' hands? Even if you knew I want lean and agile, right? If you were manufacturing something for consumers, you still had to press a CD, distribute it to the stores. They came into the stores and got it. Now, you can give them software, well, as fast as you can make software. There's no longer any bottleneck on the delivery end. And this is just, it's hard to realize this because you've grown up in a world where I just download the software. What do you mean? And if it's a website, you don't even download it, you just click reload, right? The new version just appears for you. It's hard to imagine what a gigantic change this was to have instantaneous, cost-free delivery, essentially cost-free, right? You need the bandwidth, right? There are companies that realize the impact of this, and they realize that we shouldn't be releasing a new version of our website. There was, I think it was Albert, like a year ago, we got emails. A new version of Albert is coming out. And I thought, we're on the internet. Why are we having versions? Well, why don't we just keep improving the software and just keep putting it out? So it's better and better, right? Just whenever you have an improvement, put out the improvement. And the version 1 of your software just transforms into version 2 of your software. There's no real point where you can say, well, this was version 1, this was 2. Sometimes you might want to rework things at a fundamental level. So we had Indra working with a Django server. We wanted to cut it over to Flask API server. Well, that's a fundamental change. There was a break there. But most often, you don't need to do that sort of thing. And companies like Amazon and Google are realizing this, that this is really a whole new thing. By 2013, now this is 6 years ago, Amazon was putting new software into production on average, so this is 7 days a week, on average every 11 seconds. Every 11 seconds. Now, this is 6 years ago. It's much faster now. I don't know what the rate is now. But every 11 seconds, some new feature was going out into production in some phase of Amazon software. This is fantastic. This is the ultimate of agile and lean. So what is this? What is this DevOps thing that came in? Okay, that's great. What else do we need? Well, there were a group of people who were extremely distressed by this whole thing because their whole mindset, their whole way of operating was, wow. It put a little trap for me there. It's a little professor trap. See if we can catch us a professor. These people were in operations. Operations is something in your computer science education you don't really run across too much. You know, I've talked, how many people know what a system administrator does?
Manage servers.
Yeah. So this is, when you get out in a corporation, you're going to find that about half, maybe 30% of IT, depending on the place, is this whole area you've never heard of, right? Operations, they're keeping the systems up and running. That's their job. And you know what they hated most of all? The people in charge of keeping the systems up and running?
New version.
New versions! This was the worst thing in their lives, was new versions. Because what did new versions mean? To them, new versions meant for 3 months the system's going to keep crashing. For 3 months, these operations people carry pagers, right? I think they often still have pagers because rather than a cell phone, the pager, you're not allowed to turn it off, right? And it'll wake you up at 3 a.m., right? You can't say, oh, I had my ringer off. You wear the pager. And this meant their pagers were going to be going off at 3 in the morning, 4 in the morning for months, and they were going to get woken up and say, get down to the data center, the system crashed again. They hated releases. They wanted software released as little as possible, as rarely as possible. So agile developers, lean agile developers, are at war with traditional operations. They're the enemy. These bastards are trying to release software every day. What is wrong with them? We would hope, our ideal would be they'd never release software again. And then we could get everything running smoothly and just leave it running smoothly, and we could relax and, play some video games, and every 6 months we get a call because someone's PC went down or something. That would be the life. Releases every day, every 11 seconds? This is madness, right? So there was a war. What we had was agile lean, versus operations. There were some people in operations. Now the reason, why didn't operations just win and defeat the agile and lean people? Well, the biggest reason was there's companies on the internet who keep releasing new versions. So they're a startup, they don't even have an operations. They have 6 people and everyone does everything. And they just know they want to put out software, and they're kicking the butt of the people who say, well, we'll release version 2.0 of our website in October of 2020. And meanwhile, this startup company has released 15 versions this month. And the people are going, we know we've done stuff like this for years, but boy, we're getting our butts kicked by this. These people are working in a garage, in their parents' garage, and they're kicking our ass. What can we do about this? This is terrible. People began to realize that the companies that were releasing all the time, they were putting new features in the user's hands fast, and just as importantly, maybe more importantly, they're getting feedback from the users. And the users are telling them, hey, that feature is great. That feature, that's useless. Could you change this feature so it does this? This one is nice, but if it did this, we'd like it even better. They can get metrics. They can study and see how the features are doing. We're going to look at, they do A/B releases, A/B testing, blue-green releases. Many of these companies were able to put out several versions of their software at once and see which one was working better. There was an engineer at Amazon, and we see distributed intelligence. He's writing code, and he said, we could, based on what they're looking at, we could give them a few recommendations. Like if they're looking at soil, maybe they'd also like fertilizer or a watering can or a garden trowel, right? And his boss said, no way, we can't do that. It's gonna drive them, it's gonna distract them, they're just gonna leave the website. You know what the guy did? He just made his own version of Amazon's website, and Amazon had the ability to run multiple versions, and released it to Gary, Indiana, right? They had the ability to control who saw this by region, and then took stats. And a couple months later, he came back to his boss and said, sales are up 30% where my feature is out. His boss said, oh, I guess I was wrong. So he just went ahead on his own and released his own software into production, no authorization, on a small test, and was able to show that this, maybe we all regret that he did this because we all buy more stuff now from Amazon, but Amazon's happy he did it. And it was this flexibility that he could do this on his own and have different versions running. He didn't have to take over Amazon worldwide. And they got feedback. The feedback was sales went up significantly. Oh, so we should try to sell people multiple related products. Okay. So these people were winning. And so some people in operations said, we can't be a roadblock. We can't act to stop lean and agile. That's not going to go over. What we have to do is we have to become lean and agile ourselves. We have to transform operations. Operations has to accept that software is going to come out all the time. We have to accept that the programmers themselves have the authority to release software. We have to accept that there will be defects. We have to be able to recover from them. One of the people who had this insight was named Patrick Dubois. I'm not going to, you're not going to get tested on his name, right? I expect you to know what lean is, agile, waterfall. These are important concepts in the area. The person's particular name, if it turns out you wind up in a situation where you need to know some of these names because you're organizing DevOps conferences, you learn them, right? But his name happened to be Patrick Dubois. He was one of these people who was a system administrator, and he was saying, we really need to get agile ourselves. We can't act as a block on agile development. What I'm going to do, so this is operations. These people are developers. He said, I'm going to make a conference, and I'm going to bring the leading agile developers together with, he's in touch with the top operations people who are thinking, look, we have to support agile. So I'm going to have developers and operations together. Developers and operations. I'm going to have a conference. What should I call it, Tirapal? DevOps. That's a good name for my conference. I'm going to call my conference DevOps. It just was the name of a conference. It wasn't supposed to be the name of the whole big movement or anything, but it caught on. And this is why the course is called DevOps, because it arose out of, we could call DevOps agile extended into operations. That's essentially what DevOps is. DevOps is the ideas of agile development taken and pushed into operations. To show how much the mindset changed, I'm going to give you a little story. This is one of my favorite stories from the whole area of DevOps. Operations idea in the waterfall model, this stuff came out, it was horrible, it was buggy, it crashed all the time. When you finally got it stabilized, what you wanted was it stable, then you wanted to keep it stable and unchanged for as long as possible, resist as much as you could that new release. When finally the CEO demanded you do it, you go, okay, we're going to have 3 months of hell, and then we'll resist the new release as long as possible. Again, keep everything stable. We want nothing to ever crash. Nothing ever goes down. In April of 2011, AWS, Amazon East, which was northeastern North America, crashed. I forget the details of why it crashed, but the entire Amazon East region went down. A company like Etsy crashed. Their websites crashed because they were relying on these servers. They were on AWS, right? So they're running on the Amazon cloud. Amazon East crashed. They crashed too. Netflix was the largest Amazon customer. Amazon East crashed, and Netflix basically saw no disruption of service. You know, people might have noticed their videos were loading a little more slowly. And this immediately led to rumors. Netflix was the biggest AWS customer in the world, and people said, see, Amazon, they're favoring Netflix because that's their big customer. That must be why Netflix didn't crash. They're doing something special for Netflix that the rest of us customers aren't getting. In response to these rumors, Netflix published a white paper on Chaos Monkey. And they described, here's why we didn't crash. It turns out sometime before, the people thinking about the Netflix network had authorized and developed a program called Chaos Monkey. What Chaos Monkey did was randomly roam their network and crash things on purpose in production. By crash them, what I mean, it just shut them down. Just remove them from the network instantly, no notice, no warning to any other servers in the network. And realize these things, an operation like Netflix or Amazon or Google, it used to be you put up a web server, right? Google was running on one Sun workstation for a while. Now you have load balancers and redirectors and content managers and customer lookup managers and billing managers. There's a whole network, each of which may be dozens or hundreds of servers in this network, all talking to each other. Netflix deliberately wrote a program that roamed around their network of servers and just randomly yanked one out of the network. And why would they do this? Why? It looks like, this is what a hacker would try to do to you. Why is Netflix doing this to themselves?
To make sure that service doesn't interrupt.
Because whenever a server went down, if there was any interruption to service, Netflix said, figure out why was that server so important? You have to be able to run if that thing goes down immediately. We need a backup. We shift over to the server in Asia and hit that one instead. We instead do this. Whatever we do, we don't go down. This does not interrupt our service. Maybe the video's a little slower. Maybe you can't sign up for a new 3 months right at the moment. You say, this feature will be back in a minute. What you don't do is just have Netflix, unavailable. And they had been running Chaos Monkey for a while, and they said as a result, when the entire Amazon East region crashed, we just kept running. So rather than taking the attitude that everything will always be perfect and be just as we planned and be perfectly stable, Netflix said, no, there's going to be chaos. Things are going to be unplanned. There's going to be unplanned disruptions in the network all the time. Let's make our network anti-fragile. That's a word that was developed by Nassim Taleb. He teaches in our finance and risk engineering department here. If you walk past the cafeteria and look on the bookcases, you'll find the book Anti-Fragile by Professor Taleb. But the people in DevOps have picked up on this idea and said, yes, we don't want our systems to be stable, right? Because stable systems, like rocks, are stable, right? But we can't be like a rock. We need to be more like a living organism, whereas if it gets stressed and the stress doesn't kill it, it actually makes it stronger. So what happens if we go weightlift, right? What you're actually doing is tearing your muscles, damaging them. And then you rest for a couple days, and they repair themselves, and now they're stronger. You're making yourself stronger in the face of stress by stressing the system. So this is a transformation in the way operations came to think. What in the DevOps operation does not look for stability. It looks for anti-fragility. So this is what DevOps came from. DevOps includes a bunch of technical products. Maybe we shut that because it's a little loud there. Thanks. Yeah, thank you. So let's list these products. So a crucial thing is, though, that the tools are not the heart of what's going on. The tools are there to support this way of working. So DevOps is first and foremost a way of working. We had Tom Limoncelli, Stack Overflow's chief site reliability engineer, come in, and he talked about this DevOps as a way of working. And he said, so here, for instance, is me applying these ideas to a situation that didn't involve software or software tools at all. He got to Bell Labs, and he found out that when a new person came, it took about 2 weeks before they could really start working. Because it took this long to onboard them, to set them up, to get their user ID, to get their email, to get them the proper access. And he said, well, how could this be? We're Bell Labs, right? This is the people who developed Unix and C, C++. We're Bell Labs. How could it take us 2 weeks to get someone started working? This is absurd. So he looked at it as a system that must have certain bottlenecks in it, where if we can make a small change that will fix a bottleneck, we should just go ahead and make that small change. We don't necessarily need, he didn't have any authorization to rewrite the onboarding process, which was probably controlled by human resources. So, but he said, I just looked for the bottleneck, and I realized the biggest problem was HR would not tell the department the person was starting until they arrived. And he asked HR, could you let us know in advance? And they said, no. God bless you. I've heard of this at other companies. I'm not sure why HR departments are like this. They seem to say it's a privacy concern. It's like, they're starting work at our company. That's a private fact. You know, I'm not supposed to know. I'm the person's manager. It's private to that person when they're going to start working with me. But for some reason, HR departments are reluctant. So he said, what I did was I bribed the secretaries. He went over, he talked to the HR secretaries, and he said, listen, we'll give you priority service on your computer if you just let us know as soon as you know the person's start date, just tell us. They said, then we onboarded people in 2 days instead of 2 weeks. So he made a small incremental change to a process that resulted in a big improvement. It instantly made things better. I don't know. I don't want to recommend bribery to my students, but in this case, it worked. The onboarding process was tremendously smoother. It didn't involve any piece of technology. It just a piece of information had to arrive sooner at a particular place. It just had to be freed up. But if we see our goal is to rapidly and reliably get new software into the hands of our users in order to deliver value to them and get feedback from them, then we can understand the various tools we are going to use. So we're going to use Git and GitHub. This is so we know what each version of our software is. It's tracked. We can also have multiple people working on the software at the same time and merge their changes. If we have a problem, Git allows us to roll back to an earlier version very simply. We're going to use automated testing because if we're going to allow people to rapidly put their own changes in software into production, we want a reliable test suite that it won't catch every single possible error, but it will catch most errors that might be introduced automatically, and it blocks the software from going out into production should one of the tests not pass. So this is called a CI/CD pipeline. Continuous integration, continuous delivery. Everyone's work is integrated regularly. Continuous is a bit of a misnomer, but regularly people's work is integrated with the work of other people. If it integrates properly, then it's pushed out into production. We need to automate that. It used to be that if you said, oh, you go to your system administrator and you'd say, I need another instance of the Oracle database. We need a second one. He would say, okay, I'll spend the afternoon today doing that. Okay, I run this command, start Oracle, add users, then I do this step, and then I have to set these permissions, and we need this environment variable, and we are gonna, we have to assign the IP address. Let me add that to the host table. So typically, there was an extensive hand-performed process of doing something like this. And what happened? Well, the new database server would come up. You go, I can't access it. Oh, yeah. Oh, I forgot to do this. Oh, yeah, now you should be able to access it. Yeah, I accessed it, but now that table it's really slow. Oh, right, I forgot to create the index on that table. Let me create the index. And this happened all the time. You can't put new software into production. I assume Amazon is doing it now more often than once a second, right? You can't do that with this kind of hand configuration over thousands of servers. This configuration has to be itself automated and put into scripts. And then we need to monitor the software once it's up, so right away we know if something went wrong. Then there are some DevOps tools like Slack and Kanban boards, Slack for communication. Kanban boards came directly from Toyota. They're our way of managing work. They're a pull system. We'll talk about what they are. So these are the main tools. So this is version control, right? These are the main things that we need in order to achieve our goal of being able to rapidly and reliably deliver software to our customers and get feedback on the software we've delivered. The biggest change, and then we're just about done here, so have no fear that I'll keep chatting for another hour. The biggest change that you should prep yourself for is work in small batches. This is something I learned. No one was telling me. The ideas were out there. The original Unix developers had the idea to deliver a working version of the tool, a minimum viable product. They didn't call it that, but that's what it was. Quickly, and then just add features as the users need them. Then gradually over time, I came to realize, when I started out, I would want to take a program that was going to, let's say the program was going to be a couple hundred lines. Well, what I would do is I'd sit down, write a couple hundred lines of code. And I'd have a couple hundred bugs. And I would spend a couple hundred hours crying and getting the bugs out. And it took a long time for me to realize that I could proceed much, much faster by writing 3 lines of code, 4 lines of code, testing it, seeing did those 3 or 4 lines work. And if they work, now write the next 3 or 4 lines. It's really incredible how small your batches really should be to optimize your development process. As I said, it took me a long, long time to really convince myself that I was slowing myself down and giving myself more work by trying to write everything at once. If you do that, here's the way your work proceeds. You go, boom, and then you test for a while and get your bugs out. Then you go, boom, and you do this. And you go, boom. And if you do little batches, here's the way your work proceeds. You don't have these long plateaus. At first, you're going to think, I'm really slowing myself down, stopping myself. I just wrote this one little calculation. That's only a tiny part of my whole program. Why should I'm not going to stop now. Let me get the whole program working and with the calculation in it. No, you should stop. You should write a test for that calculation, run the test, make sure it's working, and then go on and write the next feature. And it's hard to believe. I know it's hard to believe because it took me a decade of continually experiencing this to really come to believe that, yes, I go faster by going in tiny steps. So this is going to be the biggest transition because I know I was a college student. The way projects are done, you get a project in September. About December 4th, you get a bunch of caffeine and Red Bull, and you say, okay, I'm staying up for the next 4 nights, and it'll be done, right? In this course, we're going to make it a requirement to do regular small batches of development. You've got to adjust your mindset. And you're going to find, I think once you do it, someone said, I've consulted with a lot of people on this, and if they've managed to convince themselves to give it a good try, I've never seen anyone go back. I would never want to go back to coding the way I used to. You got a lot done fast and then found out it had lots of problems, and they were much harder to find. If you write 4 lines of code, 5 lines of code, and you run the program and there's a bug, where's the bug? It's in those 4 or 5 lines. It's pretty easy to find a bug that's in 4 or 5 lines. If you write 1,000 lines at once and there's a bug, where is it? Somewhere in those 1,000 lines. It's a lot harder to find it. So Again, I apologize that we had some screw up with classes. We're going to go back and we're going to have it fixed up this afternoon, and you'll have access to the website. Where over the next week, we're going to post the projects that all of you are going to work on, doing regular incremental development on these projects. I'm telling you what the most important part of the course is right now. So just hang on 1 second. Doing regular incremental development on these projects will be the bulk of your grade, okay? So I really want people to say, okay, I'm going to give this incremental development idea a serious try. All right, now I'm done talking, so see you next week.